Alright, time for another DraftScience video presentation. Yay! So a couple of comments, and hopefully we'll get to a Miles Mathis has done another paper on the double slit experiment, but it doesn't really say anything new or anything relevant, frankly. So it's probably not worth mentioning, but I'd like to get to that. But we'll see if I can get through these two comments, because you can make every sentence somebody speaks almost, you can dissect it, and point out how, Anyway, so this guy says, I'm actually a physics PhD student. Okay, now, I don't know whether to believe that or not. Because it should have occurred to you that, wow, physics is really broken. So what's your PhD going to be on? Because there's so many elements of physics that are so bad that you could do a thesis on any one of the subjects and just point out how there's no evidence for these silly conclusions. They still haven't figured out how a beam splitter works. Right there you could do a paper. Anyway, and I completely hear you, man. Well, whatever. Physics stack exchange is full of assholes. The whole planet is covered in asshole. And that's a real big problem. Miles Mathis is an asshole. Everybody's an asshole. To some degree, or lesser, I suppose. I'm an asshole sometimes. I've made asshole videos and had to take them down in 6 hours. And, because they were stupid. I've made mistakes. Let's see. They have deleted many of my questions. Well, see, that's what you should post here. I'd be interested in what your questions were, and we could discuss it or something as well, even though they are well founded in literature. So I don't know what that could mean exactly, but okay. Yeah, I don't know what it means. I can argue that everybody could argue using clay as a way of measuring something's energy isn't very scientific. Anyway, no one on this stack exchange has the guts to face their ignorance. They're obviously not ignorant. They obviously have gone to some effort to be not ignorant. What they are is misinformed. Okay, so that's a kind of a difference. That is a form of ignorance, but technically, all right, they have some reason to believe they have right answers. The question is, they should also have the capacity to recognize when they haven't really done their job of proving something. Their proof is thin. And then they could just make the argument, well, this is why I believe it. They could say something like that. Okay, I believe it because I find this piece of evidence persuasive. Even though it's not very much evidence, I find it persuasive. That kind of thing. But they don't do that. Instead, they say Eddington proved, or they say Thomas Young proved. No, didn't happen. And leave a question if they can't answer. This whole idea of closing threads as if there's some sort of horror that people would continue to discuss something. That somehow they can't allow this horrible waste of time, that people who are interested enough to post comments shouldn't be allowed to post comments because somehow they know they're wasting their time. That nothing can rise out of any of that. So this sort of relates to the next comment, which is dissing the functionality of this channel now. When I would argue that even though I have, it has gotten redundant, there are little pieces of stuff that just fall into place every week, in my opinion. I can see it. I see it. Maybe you don't see it, but I see it. And those little pieces, okay, are important in the sense that they didn't look important, but they're really important. Some of them. So there's value in picking and picking and picking, because the truth is going to be made out of that detail. The devil is in the details. Well, the truth is in the details. Okay, either way they will downvote it, close it, or give it shitty comment or an answer. Or give it a shitty comment or an answer. Okay, so that's not very well written. But whatever. College ain't what it used to be. I'm not the grammar police, obviously. I mean, I'd get a lot of points off for bad grammar. Anyway, they think that if they can't answer a question, somehow the question has a problem. Well, and they don't want to answer a question in any other context than what has convinced them, which is mathematics. So, somebody told them, that Newton said F equals ma, when Newton didn't say that. He said F equals change in your momentum over whatever time period you want to use. And that'll tell you the rate at which a force, okay, is affecting something. How much per second it's hitting it, or how much per minute, or how much per the entire interaction. And so clearly Newton's saying force equals momentum. Force changes momentum, and it's just a fact. And the change in the momentum is a way of defining the force. That's what the force did. It changed your momentum. So you may as well just say the force has momentum. Might as well. And they changed that into some kind of F equals ma. And because F equals ma, mass times acceleration, somehow I should multiply the acceleration times the velocity, which is in some cases the same thing as squaring the velocity, I suppose. But it doesn't make any sense. There's no evidence that this happens. The experimental evidence sucks, and yet they just keep saying it because that's what they believe. Because they believe they have a mathematical formula that says so, and they think the formula is rational. When clearly you could show them the formula is not really rational because it didn't exist until 100 years after you already declared it to be the truth. And it's just a contrivance, clearly. They don't want to admit any of that. They don't want to admit something obvious like, well, momentum is pretty much just weight. So why don't we just weigh things, and then we can know how much momentum they have. Because momentum is just weight, in a direction. You hit something, you apply a pressure to it, that's all there is. So if I put a scale here and then I move you, okay, your weight will be dependent on how much I move you. And that's the same thing gravity's doing. It's giving you momentum. That's what the forces do. They give you momentum. So anyway, I'll see if I can get this guy to interact. But you're sort of guilty of the same thing you're complaining about, in that you're not interacting. You don't have any physics videos, really. You're not engaged in any kind of conversation about any of this fundamental conclusions that physics has drawn, or exposing any of the bad videos on YouTube, or you don't seem to be playing as if you're a PhD student who finds physics to be questionable, much of the physics. So, I don't know, are you a real or are you a fake? Who knows? I'll see if I can find out. Anyway, 11 years and you haven't been able to talk debate to one physicist, not even a college professor. Well, that would be kind of a high standard, a college professor, actually. That's kind of hard to get to because they have a lot to protect. College professors don't want to, for no good reason, damage their credibility. They have a lot to lose. Let's just put it that way. But they also should be well practiced in the exercise, because they get student questions where a student might just ask some kind of simple question. Well, how come, for 100 years it was, the whole definition of energy was way off. They were saying there was 1,000 joules when there was only 500. That's pretty far off. Why are we saying that was good physics when, that answer sucked? But they thought it was the truth. Well, why couldn't the truth you think now not be the truth too? If you could fool them once, why can't you fool them twice, right? You were all fooled for 100 years and we're accepting the wrong answer. Maybe you did it again. Anyway, something is just not right here. Well, see, I have talked at least to some physicists in the sense that you attempt to interact. Like they have a physicist thing where you can pay them for a phone conversation. And so I signed up and I was going to pay them. And I even offered to pay them extra to allow me to record it. And they wouldn't. So You know, what can you say? Um, you know, pretty lame, really, right? And then I have that other retired professor who, yes, he'll talk to me until he finds out that I'm going to talk to him about how, weakly evidenced his physics is. And then all of a sudden he doesn't want to have that conversation. He wants to have a conversation where he tells me what the truth is. And I go, oh, yes, oh, that's very interesting. But he doesn't want to be challenged. All right, and then I could point to AB Science. There's a PhD physicist or whatever, and totally evasive. Anyway, something is just not right here. That's the way the world has run forever. Do you think we got into the Civil War because people could have rational conversation? Because if they could have a rational conversation, right, you could point out, oh, look, what are you people defending? Okay, we created democracy, you don't like the outcome, and so you decide to blow it up. You do know that that's being kind of unprincipled, right? So that's not very good principle. And what are you trying to defend? Oh, you're trying to defend your right to be a racist. Well, okay, sure, you sort of have a right to do that. But let's say you're a racist and you think somehow they're inferior. If we find an animal's inferior, we make a zoo or something and we create a preserve for them. We don't sit there and enslave them. So, I mean, we're already way past doing that kind of crap. So, I mean, come on. What are you gonna put chimpanzees in slave camps because you find some utility in their function? No, you wouldn't even do that. So you can't justify any of this crap. So grow up. And you're going to lose anyway. So don't be stupid. Really, just don't be stupid. Anyway, but they didn't have the conversation. I mean, the war we had with Japan was so stupid, right? Because it all focuses on, oh, well, they ate some Chinamen, and, we can't let people eat other people. That's no good. I mean, what? Come on, don't be ridiculous. Too ridiculous. There was clearly a reasonable dispute between China and Japan over some territories that were on the border of China that are, in proximity to Japan. And, so there was a legitimate dispute. And instead of being a fair moderator of the dispute, we chose sides. And that was just kind of lame. And then we chose sides and decided to impose a draconian penalty that couldn't lead to anything other than either a war or the destruction of Japan, right? So you were either going to say, well, we'll destroy the Japanese country by forcing them to eat each other because we'll deny them any energy resources. We'll completely stifle their economy and the function of their civilization with our embargo. Or they're going to have to go to war with us. I mean, we didn't give any other choices. Well, anyway, I'm just saying, so the world's always run on bullshit. And that's just a sad, pitiful fact. And why? Because the intellectuals are gutless pieces of crap. The smart people have no balls, no interest. They're just self-absorbed idol worshippers. They're just rubbing each other's little silver heinies. They all think they're just such golden, beautiful things. They don't have to do any work. Anyway, there is no progression anymore, just forever stagnation. Well, I'm just saying, the human race has been a slow learner forever. I mean, Pasteur showed up and pointed out something so fucking obvious. Oh, you know why it seems like there's contagious diseases that have something to do with the fact that one person is a carrier and he gives it to other people? It's because they're little germy things, right? And he points out how, you can kill them this simple way. You wash your hands, do a few things, and then you don't get the germy things on people. And it took forever for the medical community, and they still can't do it rationally, right? I mean, how many medical professionals have you seen that seem to have no fucking clue what a germ is? I mean, it's so bad. But I'm just saying this, it's because people are stupid. I don't even think most of your subs even understand the basic premise you are presenting coherently. Yeah, well, look, the average sub isn't going to sit there It's a lot of information to do physics. Okay, there's lots of subjects and they have lots of details. So somebody has to be patient enough to order all of that. Well, let's see. Photons are really radio waves all the way to gamma radiation, but the specific ones we see, and lots of details. And so most of the people don't want to be bothered. They don't want to know all the details. So because they're more interested in some other stuff, they want to look at, animated 1 minute funny images and cute kitties, and they just don't have enough interest. That's just another sad fact about human beings, is that they're not very compelled by the truth, knowing it. Okay, most humans are just not interested in this. Yes, well, that's most humans. Obviously, the people watching these videos are a little bit interested in some part of it peripherally, obviously they're watching. But yes, there doesn't seem to be too many people who have much information watching. So they're only getting their information from what little portion of my videos they're watching, which is always just a portion anyway, right? Most of the videos aren't watched by most of the viewers. It's just another, big percentage already turned this video off. They're, oh, this is a boring one. He's not yelling at anyone, something like that. All right, so anyway, this 2014, 2016 was probably when you got the most feedback. Well, obviously, and it was easy to do feedback because I was really, it was really draft, and so lots of counter arguments could be made. But now the counter arguments have to be more and more specific and more, they have to be really good, because actually what I'm arguing is so clearly correct that it's going to be hard to shoot it down. Okay, so the ducks I'm presenting aren't big, fat, lazy ducks anymore. They're really fast moving, good ducks. So yeah, it's harder to shoot it down. You honestly have a better chance going to college and getting a physics degree. So again, you think having a physics degree would change something in some dramatic way. Well, the guy who just posted is working on his doctorate, and he finds it frustrating to have a conversation with a physicist. So I don't know. We have to take that with a big grain of salt. But anyway, I don't think it's that simple. So what do you think would happen if I went to go get a physics degree now? Okay, so I'm a 61-year-old guy in a classroom full of whatever, fetuses by comparison. And what do you think is going to happen? I mean, I already pointed out that every subject now I've got a better theory than their theory. And so do you think the professor is going to let me ask my questions? And do you think, no, that's going to happen? And it's just a math test anyway. We know that physics isn't really conceptual mechanical physics. It's just a list of equations. And as I pointed out, the equations are easily critiqued as being bullshit. Like the 1/2 mv squared contrivance. Doesn't have anything to do with Newton. All right, to have any shot of making your arguments more vocal to the masses, I don't see, again, you're missing the point. This isn't about the masses. This is about intelligent people. Intelligent people lead the sheeple. Okay, and what are intelligent people now doing? They're just lying. They're just saying, who'll pay me the most money to say the most stupid things, and I'll say them. They're sold out. They have no integrity. They're intelligent. They've been educated, but they're scumbags. They're just greedy, selfish scoundrels. They haven't learned anything decent. They've been raised by pigs, frankly. Assholes. Not to value knowledge, and not to value the right answer, not to value the truth. Just to value your propaganda and your quantum sleigh ride. They're just selling sleigh rides, Knowledge is sadly pointless without some form of power. Well, that's just a truth, yes. And unfortunately, it's a rough one. And, a bunch of silly billionaires are now running the show. The agenda of the world is being run by the little Google turds. And the little Bezos turds. These turds are running the show. And it's a sad fact. Shit, it should bother people. And instead they celebrate these assholes. Lots of smart people watching every little launch of the little fucking tin can piece of shit. Lots of them buying Teslas. Ugh, this is pathetic. All right. So we made it through the 2 comments. I believe we did do that. So on to something better. Miles Mathis. Okay, so new paper. And 2-slit experiment revisited. He doesn't really revisit in any way. So this sort of relates to the video I did a response to, which was the one by Huygens Optics, or whatever it's called, right? Something like that. And this is the doing the experiment with a microscope kind of crap, and the whole idea of single photons, which has always been suspect. And so it's another one where he's using a mathematical calculation to say, there, it's a single photon because the math says so. And that whole assumption is based on some sense that a photon is infinitesimal point, when a photon isn't an infinitesimal point. A photon is a big fat thing, with a length. Right there, the calculation is crap, and obviously I would argue there's no single photon. There's just a lot of pieces. So Miles's perception is that everything already creates, everything's already radiating these photons, and that somehow your new photons are just interfering with the existing photons, which he accounts for as part of a charge field, which sort of makes sense, but it doesn't make sense without recognizing that there is a distinction between these photons. So you can't really say that the visible light photons are interfering with infrared photons, for example. That's a real leap, okay? And there's no explanation of how the leap makes any mathematical sense or acknowledges what you really have to explain in the experiment. So he links to his own, I already solved this one 13 years ago. Okay, so he didn't solve anything 13 years ago, and he argued in his 13-year-ago paper points that aren't even true. So he fell for the crap that they actually did detector experiments, that they actually detected photons, which of course they didn't do. And that, when they turned the detectors on, the pattern went straight, and when they turned the detectors off, the pattern was back. None of that ever happened. Those experiments don't exist. You can't even physically imagine how they could do them, let alone do we have any evidence that anybody ever did it. You can't detect a photon passively. And a photon, frankly, is it's an event that you can't even detect with an electron or an atom. You have to have a bunch of atoms to detect a photon. And everybody should already know that, frankly. But I mean, you can make a logical proof demonstrating it, and in the sense that all the experiments that detect photons involve circumstances where there's not one atom. Just not happening. And that all these experiments are based on, you have to be really clear about what they're doing, when they're making generalizations. So they detect what a million photons are doing, and then tell you what the individual photons are doing based on the millions of photons. And that's where all this breaks down. So I've already gone over some of the reasons why you should understand, when they say a beam splitter, the beam splitter is obviously not doing what they think it's doing. And so you have reason to understand that a photon isn't exactly what they're saying, and even if it was, well, I won't even concede that it was. So you have the idea beam splitter is just basically putting a bunch of obstruction, right? So all you're doing is obstructing, creating a bunch of slits, okay? And so this one has this one reflects, this one doesn't, this is a hole, this is a hole, this is a hole, this is a reflection. So that's the half silvered idea. And the idea is that a photon that hits and reflects, that's all it does. But obviously a photon that goes through the hole, well, we know that causes diffraction. That is, the photon diverges. It could go this way or it could go this way. See, now we're back to group behavior, right? Because they think the individual photon goes everywhere, where clearly you can understand that no, it's a group behavior. So one photon will go, will hit one electron and just go this much of a deflection. Another one might hit 3 electrons, go with this much of a deflection. One will hit an electron going towards them, one will hit an electron going away from them. That'll change the deflection. So overall, over time, there's an even number of photons going all of these directions. But we know, and obviously that could look like a wave, but any one photon just takes the one single path. Okay, now we're saying the word photon, right? But what do we mean by a photon? So that's the tricky part. So I'm just saying a beam splitter obviously isn't creating two equal beams. One beam, okay, goes through the whole experiment without diverging. The other beam is diverging. That is, it's spreading through the whole process. So obviously quite different beams. So getting it back to... All right, going back to what I just said about even just the word photon, right? So to understand what a photon is, again, I think you have to understand that a photon is a sequence of events. We'll just say it's 4. And the idea is that what the photon is a quanta of energy, a group of quanta. They come at a frequency, okay? So this is the frequency, and they have a polarization, okay? A size in terms of their arrangement going through space. And so each one of these individual bits could go different places, and you could understand that if I sent them different places, and let's say I send a whole bunch of them, I have a bunch of little bits, that there's a kind of a 50-50 chance over here that this one will be in the same period, back to the same frequency as the other bit. So I can make this path length a full, frequency, a full wavelength longer, and then I would have the same exact arrival time. Well, what I want is to have back the frequency. So I want them to have the same period between their arrival, which is the same thing as showing up at the same time. So when they draw these lines, they're not really saying, I want these two bits to land here at the same time. That's not what's happening. They're just showing that I can make this distance any distance, and so this one can show up 3 periods later than this one shows up. It's about the time difference. You want it to show up 3 periods later or 2 periods later. Well, anyway, so the point is you're just putting them back in phase. And so that explanation works. So understanding a photon as a composite object, that the quanta isn't the photon. A photon is not an object with a frequency. A photon is objects with a frequency. All right. So it's not one wave that makes the pattern. It's obviously more than one wave that makes a photon. You need to hit it more than once. And this just has to do with what's happening in the atom, which I could also go into. But I want to get just to Miles Mathis's argument, and I wanted to relate it back to heat, because he brings up heat. And the argument I made yesterday about space. But, and I was sort of making I made the implication, sort of, that you have a hot object, okay, and on Earth, and the atmosphere provides a way for the heat to escape. Now that's true, but it also creates a way for the heat to be reflected back at you. Okay, so it isn't a perfect way of losing your energy. So the argument could be made that the hot thing always exchanges just one thing, and that is the infrared photons. And you could argue, what are the infrared photons? Well, they're being created by atoms, and they're being created more specifically by electrons on atoms. So an atom on a surface, so if we just represent that as the atom on the surface, and we represent that as the electron, you could just argue that all that's really happening is the electrons are, when something's hot, the electrons are pushing the relaxed barrier. So this is the normal position of the atom, and the electrons are pushing into expanding the object. So instead of the object being this big, the object is technically this big, right? Because the electrons are being pushed out more often. So they're pushing the border line. So there's a border that is the object, and they're pushing it. Now, why is there a border? Well, that's because there's a constant force hitting everything constantly. So everything's being hit by a constant external pressure from the universe, photons. Photons that can be seen and photons that can't be seen. Photons that have a frequency and photons that don't have any frequency, you could argue, no pattern. Could be called gravity, for example. So you have all this energy, these little bits, hitting everything. And what's really happening is this represents an external pressure, or heat. So the universe has a heat to it. And it's a pretty substantial heat. It's not like a little heat, it's a lot of heat. And so what's really happening is the internal pressure. That is, there's a lot of stuff on the inside. The repulsion between the electrons is being created by the same kind of idea of two ping pong paddles, and there's a little thing bouncing between them. And so the external pressure is keeping the paddles at that position. And so if you change the external pressure, then the object expands. So we think of space as a vacuum. Well, it's a vacuum of matter, but it's not a vacuum of pressure. So the pressure is still really high in the vacuum of space. That is the photonic pressure. So that could be understood, right? Something like the words photonic pressure. Everything is being exposed to a ton of photonic pressure, and that is photonic in the sense of this, made of this elemental quanta. Okay, the little bits with momentum are constantly hitting things. And so what the hot thing needs to do is every time it pushes out, it's absorbing a piece of energy going in, right? That's when it's going to stop. The electron stops because it's absorbing the pressure from the exterior. And what happens when it does that? Well, the absorption is basically pushing into that external pressure, so it's reflecting to the rest of the universe sooner than it would have. So now the path of the pressure from the external world would have been this path, and then it would have hit an electron. But if my object is hot, then the likelihood is the electron will be here. And the path, okay, now will reflect here. So now I've taken an event that would have happened later, and I've made it happen sooner. And that's the same thing as essentially increasing the speed, right? So I've essentially increased the energy of this piece of quanta by reflecting it off of an electron at a pushed out position. I've now given this more energy. This little piece of pressure now has more energy technically, because it's going to arrive at its destination, whatever that is, sooner than it would have. So in a sense, it has more energy. And that's how the energy is dissipated in empty space. So everything's always shooting these little bits out. Okay, everything that's hot is radiating this infrared radiation, and that radiation, when we're in an atmosphere, it hits atoms, and so now it does does the exact thing I'm pointing out. It reflects the energy back, and so the more atoms in the atmosphere and the more they're moving, the harsher the reflection I get back, and the less they're moving, the less reflection I get back. And that's the key to dissipating your heat, is that if you can make these things move away, the atoms in the atmosphere move away from you, then you can dissipate more of your photons. But if they're moving towards you, that is, you're in an atmosphere where the atmosphere is hotter than you are, then you're going to be exposed to more energy instead of less energy. But it always starts with the radiation of little bits. The atoms don't hit other atoms. Electrons don't hit other electrons. They shoot force at each other. They shoot ping pong balls. Ping pong balls are the only thing that hits electrons and protons. That's it. The electron and proton can never hit each other because there's likely to be ping pong balls between them. And the rate of bouncing between them, as they get closer and closer, the rate of impacts goes exponentially high. And so the pressure, because each impact is the same, each impact is a push, right? So when you increase the number of pushes per second, you're increasing the pressure tremendously to move away from each other, not to move towards. So there's no real chance that you're ever going to bang an electron into an electron. You can only bang an electron into the force between the two electrons, the energy, the heat between them, the little bits, and just increase more pressure in terms of more impacts. Impacts are how you measure the interaction between things, the pressure. So anyway, so this doesn't really have anything to do with Miles Mathis' theory, but it's just vaguely related because he does point out charge, and so he says everything's charged. So he has some kind of theory, which is just wrong. Well, let me first point out what he doesn't deal with. So the first thing you really have to deal with the double slit pattern is the reality that Young's drawing is garbage, okay? Two waves don't answer it because there's really two patterns, right? This is really happening. There's two patterns, okay? There's this on-off pattern, and then there's this missing bit here. These missing, you have a group, and then you have a group, and there's a missing bit here, and a missing bit here. That's the same thing as another on-off pattern. So there's two on-off patterns. On-off big envelope, on-off small little bars. And as I've pointed out, the easy explanation for that is that there's differences in the distance between the slits. And this outside dimension has lots of wavelengths in it. It's creating these little ones. And this small distance has very few wavelengths in it. It's creating this big pattern. Okay, the vectors from the short distance has much fewer bars it can create. The big distance creates lots of bars. That's the truth. That's the reality. And Miles Mathis is sort of full of crap. But anyway, so he deals much more with the single photon experiment than he deals with the fact that the double slit pattern is not just an on-off pattern. It's two patterns superimposed on each other, and that's the trick. To explain that is the obligation. All right, and obviously the Tector experiments would be ridiculous. So Miles Mathis' theory, okay, and then you have the single slit, which obviously demonstrates that it's a two-source experiment, that there isn't two waves going out of the slit. There's two sources of photon, okay, of elemental bits. And it's just putting those two sources. So you're just breaking photons and then remaking photons. There's no such thing as interference. So Miles Mathis is essentially still saying there is interference. So he has some kind of theory, that everything, all these surfaces are radiating photons all the time, which of course everybody has to concede, I think, that that's true. But they're not blue photons or red photons. They're certainly not visible photons. And then he's saying that when we're putting the light through, the photon is interfering with the existing photons, and that's what's creating a pattern. But he doesn't draw it, he doesn't explain it, he doesn't do any of that. He doesn't explain why we can't see those photons, he doesn't understand how a photon even interacts with a photon. He just says because we know these surfaces are charged, they're radiating photons, but he doesn't even really mention heat. Okay, and heat is fundamental to the fact of what the radiation actually is, and that heat as a concept has to be understood that the universe, the empty space in the universe, is hot. Okay, there's no cold place in space. It's all hot spaces. Okay, and they're only cold from our relative perspective, because we're living in a very hot place, but it's not cold in the universe. If I just took a square foot of universe, okay, at any one moment there's a ton of energy flying through that piece of space. There's gazillions of the elements of a photon going, there's actual photons. I mean, you could understand that you're capturing actual visible photons in there, but there's a ton of other pieces in that piece of space. It's got a high density of activity in it. Okay, so it's not a cold thing, it's a hot thing. And that's why everything is, the atoms are really very high pressure. They have a ton of energy in them because they have lots of ping pong balls in there. Okay, because it was made inside of a sun where there's lots of ping pong balls bouncing around. So the paddles have a ton of balls pushing them out. They want to expand. I mean, if you put them if you could take away all of the little bits inside of this piece of space, all the bits pushing in, the atom would explode out, tremendous energy, because everything in the atom is about going out, and everything in the space is about pushing it in. And that's really how the thing is working. Let's see, is there anything else about Miles's? So the conceding anything, giving them any credence to this whole idea of a detector for photons is just ridiculous. So this experiment that Feynman, they all mention, is some ludicrous experiment where I put a detector here on the surface and I shot photons at the photon, which you can't do, to see the photon, which I can't do, depending on a reflection coming back or some other kind of nonsense. You can't make a photon detector. So now if I make it an electron experiment, we know the electron experiment isn't doing this, shoot random electrons and all that. It's not even doing that. And you can't hit an electron with a photon either. You can't see an electron with a photon because it's like hitting a tennis ball with a golf ball. You're going to move the tennis ball. You're not going to be able to learn anything about where this tennis ball was going, because you're completely going to change where it was going by hitting it with your golf ball. So you have no hope of seeing anything without destroying where it was going. So of course you won't get a pattern. But they never did the experiment, so there's no point in even talking about it, because they never did it. They never made these little tiny detectors and all that. This is a millimeter of space. You can't make a detector in here and do it. No, none of that ever happened. So it's all just rubbish. There's no point in arguing that. And then again, the single photon theory, in my opinion, just dies based on the fact that they don't have a theory, right? So they have a light source, and then they say, well, I'll put an opaque object here, and I'll put another opaque object here. What's the opaque object doing to the photon? What's the theory? How is the opaque object allowing a photon to get through? What is it really allowing to get through? So, I would argue that if you understand the photon is a bunch of pieces, well, what the opaque object is doing is, oops, I killed that one. That one got absorbed, and then this one got absorbed, and this one got absorbed, and the only one left is this. And then another photon way over here, okay, the exact opposite, kind of thing happened. This one got absorbed, and this one got absorbed, and this one, but this one still made it. The pieces are making it through. And then you're just sitting there doing the same thing. Their pieces are flying out of the surface at all kinds of angles. And you're just doing the same thing. You're just saying, can I, over here, take these pieces, okay, and how many of those pieces just happen to land on a surface at the right period to create a photon? That's all you're really going to be measuring. How many of them made it through, the little tiny pieces, made it through the opacancy, okay, found a crack to fly through without being screwed up, and then were able to land on a surface at the right frequency, because they already have the frequency, so their phase is already built into their path, and all you're really saying is there a path where you can put the frequency back together again? And I'd say that theory makes so much more sense than any. And again, they don't even have a theory for this. They don't have any theory for a single photon went through the opacancy. So, so all of that crap is just crap. I would argue it's you must have energy at both surfaces, and in the two-slit you must have energy at all four surfaces to create a bright spot, or a bright spot. So there must be more than one piece of a photon flying at the surface for you to have any hope of reconstructing a photon from the four sources. And you need all four sources to make the contribution, or you have no photon. That's what the dark space is showing you. The dark space is showing you that you have four, that you don't have all four making a contribution. That's the spot where all four don't make an in-phase contribution. That this is out of phase with this is out of phase with that, and that's out of phase with this. These two aren't in phase, these two aren't in phase, so you get nothing here. And if you have just one of them, these two in phase and these two in phase, you still get nothing. That's the little bars. That's the dark space in between the little bars. The dark space in the little bars is showing you that even when you have two sources, it's not enough. You don't get a photon. You need all four sources to be in phase to get a photon. All right, anyway. That's, there's so much you can go into in so much detail. So again, we just state again that Miles Mathis, just vaguely referencing the fact that there are already photons in every bit of space in the universe is filled with energy in the form of infrared or microwaves or radio waves or whatever you want to call them. Obviously I'd call them all rays, and they're rays of force. They're not rays of a force. They're not a photon. They're a composite object that makes a photon, a detectable frequency. So he has this theory, but he doesn't really show anything to back it up. He does mention, which I like, these experiments have never been done with, infrared light. And my argument isn't that you do the experiment with infrared light. My argument is that you film it in infrared and see what the pattern looks like. What is the heat signature of the pattern? Is it indicating there are actually more energy hitting the bright spots? So that would be an interesting thing to see, is how are you heating the surface? Because if they're not heating the surface with a pattern, then you could understand that the energy is going to all the locations, and it's just that the energy is in a visible photon form in one place, and the energy isn't a visible photon in the other place. But it's still energy, it's still pressure, it's still the universe hitting, that location. So what else? So Miles is a fool, for accepting detector experiments that never happened. He's also, it's good that he points out that, they haven't proven this photon thing, but he still believes a photon is a real object, which is just, again, silly. The frequency thing is a giveaway. What makes how do you make a how do you know a frequency exists is that you got to hear more than one piece of the element, right? You can't know it's a frequency until you get hit with the second object that tells you, oh, okay, that's how much distance there was between them. To think that the photon is this blob that's 1,000 atoms across, and you really think a radio wave is a round blob that's 10 miles across? That the blob has the frequency built into it, the wavelength? No, it's just a period between events. It's a period between little grains of sand, hitting something. Ding, ding, ding. That's the photon. The photon is more than one ding. All right. So that should be enough. So I wish there was more to this. Like I said, he doesn't have zero pictures, zero illustration, zero. So not much to and most of it's just a critique of the attitude of the people reciting the garbage. And the irony is that Miles Mathis is also reciting the garbage notions of photon as a object, as a thing in and of itself, as an elemental thing, when it's clearly made of the elemental stuff. But anyway, okay. I share some of his critiques here. Like he says here, remember that if you ever meet a professional physicist, mathematician, or scientist, well, he should just say a professional mathematician, because the physicists really aren't conceptual scientists. And there's nothing about, they obviously don't care too much about repeating experiments, so they're really not show meists. Okay, they really are abstract. They're much more persuaded by abstraction than they are by rigid, hard facts. These are people who have agreed to be part of a field led by people like this. So again, he's critiquing people like this who are just spouting the routine crapola. Again, just to imagine how bad does it really have to be when everybody talks about a detector experiment and it never happened. That part's just so glaring. And even again, the two-wave Young math doesn't work. I mean, it doesn't get the right answers. If you use it, you won't get right answers. You get something that's vaguely close in some circumstances, but they're really not right answers. So it clearly doesn't even work. And they still talk about it like that's the answer, when it can't be the answer because it doesn't get the right answer, and it certainly doesn't explain two patterns at all. No hope. So anyway, so that's enough. I mean, I've been over the rest of it so many times. The videos are on the website. I'll post them in the description. There's one called the photon, and it just annihilates all the nonsense that people have been told about the two-slit experiment. It explains how grossly simple it can be understood to be. But anyway, so I've done my job here. I can only reason with you, and the counter arguments, frankly, don't exist. They can't be put in any form that I deserve a response. They can't make them in any kind of relevant civil manner, and who's again, bad on them. That they're going to be so arrogant when they can't make a rational counter argument. It's just the truth. So anyway, so till the next time and such, this has been a DraftScience video presentation. Yeah, that's what it was.